where I'm going to be looking at industry-related manufacturing technologies. This is from the Industrial Technology Stage 6 Preliminary Syllabus for the timber products and furniture industries focus area. Specifically looking at fittings and allied materials. So if you're trying to find that on the syllabus page numbers, it's page 49 towards the top there. This is where we start looking at things like hardware and other materials that can be used in our projects. We specifically need to know about all those types of hardware and where they could possibly be used and why we would use them, as well as those other materials. And we need to think, why are we learning about these? Well, it's all in preparation for the major work for year 12 and then for future career in the timber and furniture industry. So you need to be able to identify those fittings, select the appropriate fittings for the uses that you require within a practical project. So let's get started. We'll start with screws. You are probably very aware of screws, but you probably didn't know there's a whole heap of detail. Firstly, you should know that screws are typically used in sheet metal and timber only. Okay, so if you're working with metals other than thin sheet metals, you wouldn't be using screws. You'd typically be working with bolts. And if you're working with materials like plastics, you typically wouldn't be using screws either. Okay, so timbers and sheet metals. You can use it to secure things to timber. Okay, that would work. So for example, trying to screw a piece of acrylic to a piece of timber, that would definitely work. But the screw itself with a thread would actually damage acrylic in most circumstances. Then in terms of types, now there are so many different types, it's hard to think of how we would categorize them. I could walk into Bunnings and there's an entire aisle dedicated to screws. They go from treated pine screws to stainless steel screws, galvanized screws. They could be powder-coated screws. They could just be regular everyday screws. They might be brass screws. They're all different sizes, shapes, configurations. There's all these funny numbers on them, G numbers, lengths, etc. It can be very confusing. But let's just work on 4 basic principles. There is the countersunk head screw. It's the most common screw that we use in the workshop and probably the one you're most familiar with. It's indicated there, that top image. You can see it's sort of got that dovetail flare out head type and it's got a very flat edge. So I'm just going to turn on my annotation laser pointer tool. You'll see it's got that very flat edge. That flat edge is designed to be aligned with the surface of the timber that you're screwing into or below it. So it shouldn't be sitting higher than. So it should be equal to or below the surface. Sorry, just going back there. You've then got this sort of little dovetail point that I mentioned. That's a specific shape. And what happens is when you plan to use a countersink screw, you actually need to drill out a small countersink hole so that that V shape can actually fit in. Otherwise, what happens is it will try and compress your timber. And if your timber is too hard, it will split it. So you actually have to pre-drill a pilot hole for the shank, but also pre-drill a countersunk hole for the countersunk head to fit within. Okay. We've then got the thread. You can see that's the curly part, the little spiral shape that sticks out. That's what actually grips on. And the greater the depth of that thread, the more gripping capacity it has, but it'll make it harder to screw into materials because it's obviously got to squish in between the fibers. So if you're working in a softwood, you can probably get away with a really large thread. Whereas if you're working in harder woods, you're probably aiming for a much smaller thread. Then the shank is the whole length there, okay, from tip all the way up to the top. The shank doesn't have to be completely covered in thread. The thread sometimes will only cover 3/4 of it, and that's totally fine as well. And it will depend on the application that you're looking for. But wherever the thread goes to is where your gripping power is. The rest of it, there's no actual gripping power. It's just part of the screw. So that's a bit of an overview of what the screw looks like. That's the countersunk, most common one that we use. There is then the raised head. Now the raised head looks very much like a countersunk, but instead of that nice flat edge, it's got that nice little dome shape there. The benefit there, it has a greater depth of slot that you can work with, okay, because there's more head to work in. And it might also be a feature that you're aiming for with a little bit of a bump, but it definitely won't sit flush with the surface of the timber because it distinctly has that raised head. In a round head, you sometimes might hear it referred to as a cup head or a mushroom head. In these circumstances, you've got a thread. You can see there's a bit of unthreaded shank there as well. Totally normal on these larger size ones. and then it's got that round dome shape, but it doesn't this time have the little dovetail fan that sits below the surface. And that's because that whole flat section sits flush over the surface of the timber, okay, to cover the hole completely, so you wouldn't see any pilot hole that had been drilled. Then if we're thinking about the coach head, it's basically a little hex screw. You can use your socket set there to put these in. Again, you can see how deep the thread is there when you compare it to the raised head or the countersunk examples we've got here. And again, part of the shank that doesn't have thread on it. So they're the four main types we'd refer to. If I'm thinking of where I've used these in my own applications, coach head screws, I've used them quite often when mounting TVs to the wall. Because of the fact that I can use a socket set on them, it means that it's really easy to drive in, and I would actually be driving it into the timber stud wall. Okay, so that's why that really deep thread there, and really enormous gripping power. Same would go for the round head screws, same sort of application, but it's usually you're using the round head because it's a little bit more visible and you don't want that ugly hex head. So maybe this would be in bedroom furniture like the frame of a bed or something like that, where you don't want people to be bumping their knees and cutting themselves by running past these screw heads. Raised heads can be used in a whole range of furniture, particularly when it's on show and there's no way around it. Countersunk is when you're trying to actually hide the use of the screw there, or make it look a little bit more seamless with the design. Here's a little bit more detail around how we screw. Now, if we're looking at this, there's a few things to point out. Top piece of timber here is slightly different color. We're going to refer to that as the workpiece. That's the piece we're trying to connect to another piece. And then we've got the substrate. The workpiece is where the countersunk head sits in. So you can see there's a countersink hole, and that needs to be screwed out. Now, I've seen plenty of tradies will go through just with a Phillips head driver and just drill and sort of carve out essentially with a Phillips head. Not the correct way. There's actually specific tools for countersink, and we use those in the workshop quite heavily. You then typically would have a clearance hole. This is going to stop your screw from splitting your main workpiece, your surface workpiece. It's usually slightly larger than the shank and the thread combined. Okay, you can see it only grips in ever so slightly there. We go down to the substrate, and that's where we've got the pilot hole. Now, the pilot hole is much smaller than the clearance hole, and you can see the amount of grip that that thread makes as it really cuts into and screws into the timber fibers there. Now, without pilot hole happening, chances are that you're going to split the material or snap the screw. So I've seen plenty of times, trust me on this, I've seen plenty of times students in their major work, they've got a piece of jarrah, they've got this nice, awesome countersunk screw they've been working with, they haven't drilled the pilot hole at all or haven't drilled it correctly, and it tries to fit through them because the density is so great, there's so many fibers compacted in this jarrah, it actually either splits or, more commonly, the entire head actually just snaps off the shank because of the amount of torque pressure that the screw is put under. Okay, so definitely, no matter what you do, always pilot hole and always countersink hole. The clearance hole is an extra bit of work, but definitely a benefit to you if you're working with a hardwood on the surface being screwed into a softer timber. How we do that, there's a bit of description there. You can pause this and go back to it. But the one thing that I'll point out here is the G number, 8G. 8G screws are the ones that we're typically using in the workshop. They've got fairly good holding power there. If we're looking construction industry, structural applications, 8G probably isn't good enough there. But for some basic applications, screwing things together, 8G would be totally fine. Okay, it'll definitely hold your frames together. Definitely be strong enough for a chair, definitely strong enough for a table and those sorts of things. Okay. When you're using an 8G screw, and this will be indicated on the packet that you buy, 8G is sort of talking about the diameter of the shank. And so it will give you a bit of an idea about what size pilot hole. You can look up any of the G numbers on the internet. It will tell you what pilot hole is required. But 2.5 millimeters is what we need for the 8G screws. So that's why if you look in our workshop, most of our drills that are sitting in there already have the 2.5 millimeter drill bit in them because the most common pilot hole that we're drilling. Now, if you've got a smaller G number, so like a 6G or a 4G, then the size goes down. If you've got a higher number, like a 12G, then the number goes up. Pilot hole, like I said, optional for softwoods, but I definitely recommend it. Absolutely required for hardwoods. Clearance hole, could be the countersink hole or a regular hole. You can drive the screw in with a screwdriver. The idea here, I know everyone is used to getting the impact drivers and just driving those screws in because it's easier and it's faster, and that's totally fine. But if you can't put the screw in by hand with a screwdriver, then you have not done your pilot hole correctly, or you have not done your clearance hole correctly, or you have not done your countersink hole. Okay? Wrong sizes, wrong length, something going wrong there. The screwdriver should be enough. It shouldn't be hard to put a screw in, but at the same time, it should bite into the timber to give you that pulling strength. The last thing that we talked about with screws, this is something most people don't know, is this process called heading the screws. So if you have a slotted head, so not a Phillips head, but a slotted head, so one single slot, you use a flat-headed screwdriver, then you would actually turn the screw so that the slot is parallel with the grain direction on your timber to head the screw. It actually makes it look just a little bit neater. It's a little trick of the trade, not many people know about it. If you've got a Phillips head screw, you would turn it as well, trying to get it exactly parallel and perpendicular with the grain, just so it's not sitting at sort of that off parallel direction. Now, screws should be used instead of nails in these occasions, when there is an enormous amount of holding power required compared to what you'd use a nail for. If you're attaching metal fittings to timber, so like a hinge to timber, for example, or if you think the project may need to be disassembled at some point. If your project doesn't need to be disassembled, then you might as well use a nail, because generally speaking, they're just that little bit cheaper, and you don't need to go with the pilot holes, clearance holes, etc. Okay, so something to think about. Moving over to nails. Nail, simplest method of joining timber, you should be familiar with it. It's usually done on its own, but you can definitely add adhesives, okay, to make it a stronger joint. And there should be enough holding power with the nail and with the adhesive to hold your project together in most applications. If I was building a house, you can use screws or nails. So there is definitely holding power in nails. In fact, most houses are made with nails because they're so much simpler to drive in with nail guns. Okay, nailing, the main reason you'd use it over screwing is when the appearance is not as important, because nails, you may need to drive more in, they may need to be closer spaced together, and they also tend to leave a small metal dent, or sorry, a metal speck on the surface of your timber, obviously the head of the nail. So unless you drive it in further, sink it in, putty over it, then you're going to have that little metal dot there, which maybe won't accept your stain, won't accept your paint. It just makes it that little bit trickier for you. So when nailing, have a think about appearance. If appearance is not important to you, nail. If appearance is important and you really want to nail anyway, that's totally fine. You just drive that nail in just that little bit further, and then putty over. Excuse me. Now, nuts go with bolts, and bolts is one of the things we need to learn about. But there are a whole heap of nuts that we talk about using. The main ones you'd be familiar with would be the hex nuts. Hex nuts are used in most applications just to hold little things together. But if there's an enormous amount of pulling power, or if there's a little bit of torque, or you need an extra amount of security, you might consider using a nylon nut. Now, the nylon nuts work very similar to the hex, but they've just got a little bit of nylon in it that actually stops them from automatically unscrewing. Really useful in vibrating circumstances. So, for example, if you're on I'm thinking about my clothesline outside. When I put my clothes on, there's weight on it, so the bolt actually moves up and down a little bit as I'm taking on, taking off. Eventually, the hex nut might naturally just unscrew a little bit and come a little bit loose. The nylon nuts, they don't back off. Okay, so they stay locked in to the original position that you put them in without any stress. Wing nuts, commonly used in applications where you might need to pull them apart, put them on and pull them off very regularly, and in applications where hand tightening is required. T-nuts, okay, very much used in knockdown fittings. These are actually hidden within the timber, so those little spikes there. Drill a hole excuse me, grip them into the timber, and then you have a nut essentially embedded into the timber. A few other options are available there, okay, but they're the main ones we talk about. Now we talk about bolts. Bolts, similar to screws when you first look at them. I mean, they've got a head, can be Phillips, can be slotted, okay, can be hex, can be socket, can be Allen key, can be a combination of. They can be countersunk, they can be cup head, they can be rounded heads, they can be hex heads, they could be socket heads. There's a whole heap of different combinations. The main difference here, there is no tip, so no pointy tip. It's a flat end. And that's because bolts are not designed to be self-driving into a material. You definitely drill a clearance hole for a bolt the whole way through, and the nut on the other end is what holds the pieces together. Okay, so key differences there. The other thing that you'll note is that the thread on a bolt is much smaller and less sharp to touch than you would experience in a screw, because it doesn't need to slice into timber grain. It just needs to have the nut slip over it and hold into position. Now, knockdown fitting. You're probably initially thinking, I have no idea what these are, and that's okay. But if you have ever assembled flat pack furniture, e.g. furniture from IKEA, or furniture from Kmart, then you have worked with knockdown fittings. It is very likely. The benefit of these, they're super easy to put together. They're engineered for their strength, and you should be able to put them together with everyday tools. Okay, so let's have a look at some of them. Cam fittings. Okay, now for a cam fitting, you basically have a little bolt running through the center. It's got a little screw thread on the end that grips into the end timber. And then when you put these pieces together, the bolt slides through this hole and into there. You turn the Phillips head, and it actually locks around the bolt and stops those two pieces from falling apart. The bolt and cross dowel, there's a bolt running through the center here. Okay, bolt, the cross dowel. The cross dowel works like a nut. Okay, you run the bolt through, turn, and it pulls those two pieces together. Again, unlikely that you'll be able to pull those apart without undoing the bolt, pulling it out of that cross dowel nut. Here's the T-nut that I spoke about. Okay, the T-nut gets embedded into the timber. The bolt goes down into the nut component, pulls the pieces together. Panel connectors. Okay, this is for almost making widening joints in panels. So you can see there's that little flat surface there between the panels. That one, the screw goes in diagonally into the bottom piece. The screw at the bottom goes diagonally up into the top piece. So they drive into each other to screw in and hold an enormous amount of strength. Cabinet connectors, you're basically working on a nut on either side and a bolt that's only thread in the center. And then they usually get used for kitchens and bedroom cabinets and things like that. The one that you will very likely come across is the block connector. Okay, these are great, simple tools, very cheap. You put them on the inside of your cabinet, so entertainment cabinet, for example. Screw, so this one here is actually upside down, so that little hole there you would actually have on the bottom. Okay, but your screw goes down into the top of your entertainment cabinet to screw in, and then you put two screws in the side, which then screws into the side of the cabinet, and it holds your 90-degree cabinet together. So it can strengthen a miter joint, for example, or it can be used in butt joint applications and things like that as well. So it gives you that extra bit of strength. And these things here you can get for around about 10 cents a piece at Bunnings. So there's a whole heap of knockdown fittings. There are an enormous amount, but they're some of the common ones that we come across. The block connector and the cam fittings being the main ones. In terms of hinges, again, there's heaps of hinges that are out there. Most commonly, you'll come across butt hinges. These are used for basic doors on top of jewelry cabinets or cabinets for entertainment cabinets and things like that. If you're going for a more advanced cabinet, you may come across a Euro hinge. You've probably got these in your kitchen. They basically hold themselves open for you, which is a benefit. And then you can actually get slow close ones or soft close ones. So when you close the cabinet, they sort of slow themselves down so that they don't slam on you. And then in a really advanced application in jewelry boxes, in most lightweight applications, maybe it's a piano stool or something like that, you can have a concealed or a barrel hinge, which fits inside the edge of your timbers to then close off. It doesn't like twisting loads, so you really need to make sure that you align those ones carefully because it can damage the hinge very quickly, and they're quite expensive to replace. So there's some hinges there. Handles and knobs, okay? You just need to know the main difference. Knob, single, rounded, handle, long, and you grip around. Okay, so they're the difference between the two, but you would know there are a heap of different styles. They can be made from all sorts of materials, brasses, metals, plastics, timbers, etc. The last one in hardware is staples, and you're probably thinking, where would I use staples? But if you've got the backing of a entertainment cabinet and you're putting a thin piece of MDF over it just to close it off and seal it, you could use staples to hold that MDF into the back of your cabinet. That would totally work. But you also may come across staples in upholstery. That's one of the things that we talk about when we move in a couple of slides through these other materials that can be used. So from this slide onwards, we start looking at what other materials. So we're no longer on hardware, but we're looking at what other materials could we use in a project. So if it's not just made from timber, what other things do we use? Glass, you're probably familiar. We might use that in the doors of a cabinet. Even in terms of mirrored glass, you might be using that if you're making a jewelry box or a dresser table or things like that. You may use metals, range of different metals, but you may use some of the decorative ones like brasses and bronzes, or you may use steels and things like that. Okay. Particularly if I'm thinking about where would I use metals, maybe in brackets, corner brackets to help hold my project together. Where would I use the more decorative ones? Brass, maybe in my concealed hinges might be made from brass. Maybe my handles made from bronze, things like that. You may also use them as decorative surfaces, okay, so to add an extra element of decoration to your project. You may use polymers as well. Polymers is a fancy word for plastics. And there's two main types of plastics. Thermoplastics, which you can heat up, they melt down, and then you can set them into a new shape. In comparison to that, we've got thermosets. These are plastics that once they've been created, you can never change the shape. You try to melt them down, they'll turn into a liquidy sort of goo and then burn, but they won't form into a new shape and maintain their strength. Upholstery. So if you're thinking of making a stool, you may be considering upholstering it, or a chair. So it's a whole heap of stuff to consider, but you've got your foams, there's inner foams and outer foams. Then you've got your covers, maybe additional cushioning. And if we're thinking, how do we apply a lot of these things? It's a combination of contact adhesives, combination of staple guns, combination of stitching and sewings and things like that. So there's a whole heap of stuff that get used there in upholstery. But again, it's another material that you may use in the design of your project. And then lastly, we talk about adhesives. Now there's so much to talk about adhesives that we're actually going to split this into its own video. So we'll pause here and we'll carry on in section 2 of fittings and allied materials. The adhesives will have its own dedicated video. Thanks very much and catch you later.